Student, are you going observing all things?
Yes, sir.
चलो वॉइस सुनाई दिया चलो.
Okay, ठीक है. Right. So see, the tool what we are going to discuss today is online AutoCAD tool. Okay, so its name is Tinkercad. So you can just see over here. There is a Tinkercad. Okay, so everyone can go to your Google and just type Tinkercad tool. Okay, so it will take you to Tinkercad website. There you need to register, which is of free of cost. Okay, so once you open your Tinkercad, okay, and once you register, you can find the dashboard like this. Okay, so here you can have different uh, design tools. Okay, so not only electronics, it is used for many other courses also. Okay, in electronics we can just go to the things. Now see here, we have certain things you can make use of the designs also. Okay, so 3D designs, you can make use of the circuits, you can make use of the code blocks, right? So all these things, these are certain small projects which I have done, so which that will do it freshly. Okay, so then you can maintain this, and you can just whatever the simulation you are going to do here, the same code for the simulation, whatever the code you are going to generate, that generated code can directly be dumped into the Arduino board, and you can execute by connecting the hardware components. So it's so easy, okay, to understand and to execute also, right? So let us start with the things. So I hope my things are clear to you, right?
So
So,
you students has to do at your end and immediately give the response.
yeah, so you can just go to the Tinkercad. Okay, so I'll just go here. So sometimes it will be little, it depends upon the speed of your internet. Okay,
How many
so
of
that
you have find out this tool online, students? Trupti,
Yes, sir.
do you find this tool online?
Yes, sir.
Have you opened the window?
Sir, I have created our account.
okay, so first create the account. Okay, then you
Yeah.
can just go ahead.
All of you
Yes,
create the
sir.
account and respond here that everyone is having that window at your end.
So parallelly we'll do that. Okay, so first you can observe it and then you can do it. So once you finish creating the account, you just put a raise your hand so that I can understand that everyone has done it.
Sushant, Sudarshan, Sakshi, Rushi,
Or you
Rohit,
can just share your emojis at least, just by clicking on the emojis. Because
Nikhil.
I require an active participation of the student for this. Yeah, so it is done, I feel so.
हो गया सबका? Didn't respond there.
See, I can understand only if you respond. So,
तृप्ती झालं का? बाकीचे सर्वजण हो किंवा नाही उत्तर द्या.
uh,
चलो, we consider it, sir.
so we consider and we'll just go ahead. Okay, right.
Yeah.
So just see here. So once the dashboard is created for you with your account, okay. So you can have 3D options, circuits and code blocks. Okay. So ours is circuits. So go to the your profile and just select the new design. Okay. So once you add a new design, okay. So it will ask for whether the design is a 3D design or circuits or code blocks. Okay, so we start with the circuit. So we have to create a circuit. So once you create the circuit, so here on the left hand side you can, sorry, right hand side you can see the basic components which you can see. So you can just hide it also, or if you want to see you can see it. And these are some basic input output devices or sensors and output devices what you have, which are used in real time. Then you can go to all. Okay, so where you have general components, input components, then output components. Okay, so with more variety of components you can see the battery sources, then controllers, any microcontrollers, Arduino boards. Okay, then if you want voltmeter instruments, you can have a list of instruments. Then with the help of integrating circuits, you have integrating circuits, you have operational amps. Okay, then comparators. Okay, the power control devices. So what not? Okay, so almost all the electronic components will be available here. Okay, so still if you want to work more, you can just do some payment and then you can just go ahead. But for our Arduino projects, this is fine. So I'll take the basic thing. Okay, so whenever we and whenever the components are there, right? So you will be basically using a breadboard to connect the input output devices. So now let us research about the component tab. Now if you see here, you have simulation option. Okay, and you have send to. So once you create a software, okay, so once you create any circuit, you can send to the other people also. Right, I got one question. Can you share your screen, Govind, and stop presenting it?
Saurabh sir, those are newly joined. Tell them what type of the tool they have to find out
So I'm
and do the
just
sign
putting the
up.
message in the chat box, sir.
Okay, okay, no issue then.
Tinkercad.
Okay, sir.
Yeah, those are joined newly. See the chat box. The link is provided.
So go to this website, register yourself for free. So once the dashboard is ready, okay, so you can ready, you need to go to the profile pic and select new project. Okay, so in new project you have to select circuit. So I'll show this process once again. Okay, so you have to go to, so once the dashboard is created here, you have to go to your profile pic. This is your profile pic. So here you can select new project or new design. For some people, you may get it as new project, but you can select new design. Okay, then under new design, you will be having three options. That is 3D design, circuits, and code block. So you can just go to circuits. So once you select the circuits, so here your components, everything will come into picture. So I hope everything is visible for you as of now. Okay, right. So uh, here you can just maintain a sample project. So I'll make it as sample pro, sample one. Here you can rename them.
S-
Yeah,
Screens. You are you
yes, sir.
sharing, sir? Anything?
Yes, yes, sir.
Yeah.
I'm sharing the screen. I think.
Yeah. It's not there.
Okay, fine. Right. So here you can go to on the top. You can go there and you can rename your project name as sample one, sample two, like that. Okay, or your name, anything. So I hope now this is clear to you. Now here you have three options. Okay, so one is code. So once you click on the code, okay, so since it is empty, it is becoming, it will be showing it as no code. Okay, now simulation and send to. So if you want to share your things to your friends or anyone, okay, you can just share this along among your friends. Okay, then simulation, everything will be there, and this is the view whatever we have, and here this is your circuit view, and this is your schematic view. Okay, and this will be the component list whatever we have used. Okay, so now let us take a simple project. Okay, simple, where we take one LED. Okay, so once you drag and drop the LED, it will ask for the name. So let us make it as LED one, and it is, we have different varieties of LEDs, like so different colors, right? So green, yellow, orange, blue, like this. So I will, let us choose green. Okay, then so in order to eliminate that, we require a battery. So we'll take a battery. So if you want to rotate this battery, you can just take it here. Okay, and right. So your battery is there. So can we connect directly to the battery? So we can't do the battery. Okay. So see here. So this is your LED, and this is your anode terminal, and this is your cathode terminal. So if you want, you can just reverse this. Okay. Now how we connect this LED? So directly can we connect? So let us see what happens if we are connecting directly. So straight away, you can just click on the node, and you can just drag the wire, and you connect to the positive. Okay. Next, take the cathode terminal, then connect this to a negative. Okay, so now let us see, start simulating. So now see here, you can see the LED glowing. Okay, so this refers that the LED is glowed. Okay, now for this, if you want to see the code, see, code is not there, because for this code is not required, because directly it is connected. Okay, so stop simulating. Now you can see the schematic view here. So this is your schematic view, right? So this is your battery, positive connected to the LED, and this is a negative connected to the LED. So once you take the components and do this, you can have the schematic straight away. And if you want to see the list of components, you can just see the list of components whatever we have used. Now slightly we'll modify this. Just remove this. I'll take a resistor so that for protection. Okay, and I'll use 1K, or if you want you can go with lesser version, lesser also. So I'll put some 500 ohms. Okay, so since this is positive, I can even change the color of the wire also. So you can change the wire as here. So I'll use, usually positive it will be red, okay, and ground will be black. So you can just select the black one, terminal 2, and then terminal 3. So now just see the simulation. Okay, now if you see the schematic view, you can see here the diagram. So is it visible? And this you can just download to as a PDF also. Okay, then see the list of components what you have used. Okay, a diode, a battery, R1. Now this is not our thing now. So what we are to supposed to do, we have to control with the help of an Arduino, right? So what you can do is you can just delete everything. Then you can take an Arduino. So if you want Arduino, so you can just type, So whatever the versions you have the different versions of Arduino, right? So for the starters, you have various digital input, analog input, how we can read everything. So we should select an Arduino, right? So there is an Arduino Uno board. So we have not configured this board yet. Okay. So this we are going to connect to the components. Right.
Many of final year students, I think so, done something on the Arduino
Yeah.
in
So they
their
would have
in project.
known how
Yeah,
to
yeah.
connect.
Yes, yes. And have they used Tinkercad or not?
Uh,
Nikhil and others. Even second year students have been learned with the Arduino as a workshop in the current semester itself.
okay. Then they
Yeah,
they will be used.
yeah, definitely. It will be easy for them then to execute.
So then we will use a
Yeah.
breadboard. Okay. So now we need to take LEDs, all the connections we need to do it. So what we do, take an LED, reverse it, and we'll connect to, we'll place somewhere else here. Okay, so we need a resistor. So resistor, right. So we are connected to the negative terminal. So this negative terminal has to be grounded. Okay, so you need to see where the ground is there in the Arduino board. Okay, so board to board the ground will change. Sometimes here you can find over here like this. So if you want to zoom it, you can just zoom the components and see how where it is connected. Okay, then your positive terminal, okay, is connected to say some, you want to connect to 12th terminal, 12th LED. Okay, so you're connecting directly to the 12th LED, right? 12th pin, okay, of the Arduino board. So is this sufficient now? So let us see whether it is working properly or not. So you start simulating. So the LED is glowing. No. Why? Because we need to program the LED. Okay, so in the previous case also we have connected the same thing, but it is not done. Okay, so now the actual part of your Arduino board will come into picture. That is, you have to go to code. Okay, then once you click on the code, you have three options. One is blocks, one is blocks plus text, and we'll directly go to text. So once you do the text, okay, so here you can come, you will get your embedded C program here straight away, but this is not done yet. Why? Because, okay, so it has to be configured, right? So if you see here, usually the embedded C program, whenever you're using for your Arduino, there will be two types of functions. Okay, so one function is known to be the configuration function, which we call it as setup function. Okay, and the other one will be the loop or any other functions. Okay, other functions. So primarily we need to set the configuration, then as per that only we have to run the program. Now let us see how we can do it. So here your LED positive is being connected to the 12th pin. Okay, so if you see, so you have right from 0 to 13 pins, that is 14 digital input and output pins what we have, right? So I have chosen the 12th pin. Okay, so what we need to do is we have to initialize the 12th pin. So int, okay, LED equal to 12. So we have to use this, and now wherever you have the LED bulletin, okay, so it has to be replaced with LED. So whatever the variable you are going to take. Next, first run this program, then we will understand how the program is working. Then we put LED here. Okay, so now let us simulate the program. Now see here, the LEDs keep on glowing. I think the students can see this. Now how it is done? So with the help of program. Now for this, if you want a schematic, you can just see the schematic here. So is it clear, students? Suppose if you don't want to connect to 12, so you want to connect that to say some say 7th line. Okay, so you can just take a wire and connect here, and you can just change the color of this. And if you don't want the LED to be red, you can just make it as yellow. Okay, or you can make it as green. Okay, so now you start simulating. So the program is not run. Why? Because you have simulated for the 12th pin, but the connection is for 7th pin. So it has to be modified to 7. Okay, so now you start simulating. Now see, it has been illuminated. Now, if you, is this understandable now? Is it clear for the students?
Yes, sir.
Yeah. So now what we can do is we are going to understand how this uh, program is working. Okay. So now, as I said, okay, so the first thing is this function. So I'll stop simulating. So the first thing is the void setup. Okay, so any function, okay, whenever you are writing in embedded C, okay, so it has to be started with void. Void means what? Anyone? Those who have studied C language, can you tell what is void?
So it returns zero value.
Yeah, so it returns 0, right? Exactly. Okay, so it is an empty function actually, okay, which will return always 0, right? So then you are going to have a setup function which is inbuilt for your Arduinos, right? See, the programs whatever we are writing here will be component or the device dependent. Okay, so if you are writing for Arduino, okay, so the respective library functions will be automatically loaded here. Okay, then in the setup we are going to have the pin mode. Now see this pin mode function. So pin mode is a function which will configure the pins, okay, like whether it is input or output. So this output, this is case sensitive. You have to be very clear with this. Okay, so you can't write a small letter like this. So you can't write like this. Okay, so output you can't write. So it should be capital letters. Output, right. Now pin mode is an output mode. Okay, and what is the output device which you are connecting is a LED. Okay, so this LED is a variable. Okay, so which is connected to the seventh pin. So you can just replace an LED. So see, you can put LE also. Here also we can put as LE. Okay, this is just a variable. So for better understanding, we are putting the name. That's it. LED. Next, the same variable has to be used further, right? So the pin mode. So pin mode is the output mode, and the which pin it is defined as an output port. That is a seventh pin. Suppose if you want another LED or another pin, okay, so then I'll make it as LED 1, which is equal to say some 8th pin, or I'll make it as 12th pin. Okay, so now whenever we are doing two pins to be configured, the same thing has to be defined in your setup as output. So this is your LED 1. Okay, so now this is your setup. Now this is loop is a continuous loop which will be keep on executing. So here we have a function called as digital write. Okay, so digital write. So this pin 7 to 12 are digital pins, isn't it? So what we have to do is we have to write onto the digital pin. We have to give some voltage there. So if you want to give the voltage, okay, or if you want to give the status as high, you have to write it as digital write. Okay, so see here, digital is in small letters, and for write, WR. Okay, so is your W is your capital, and RIT, so digital write. Okay, so is equal to LED. Okay, so what are the variable we have used, and then we have used high. Okay, so this high refers again. This is the activation what we are doing for the component which is connected to your seventh pin. Okay, so this is your high. Okay, then digital right. Okay, so in the same fashion, the same LED we'll put as the status as low. So for your LED, high means active, low means passive, right? Then for how much duration the LED has to glow, so that we are defining with the help of a delay function. Okay, so delay is a function which will delay or which will count for the number of which will count for the count whichever we are representing in milliseconds. Okay, so 1000 milliseconds. So this is your millisecond. So whenever you write it as 1000 milliseconds, it refers to 1 second, isn't it? So that's why we will wait for 1 second, and again the status is changed to digital write LED low and for 1000. So now what we do, so since we are having one LED, so we have set up as two LEDs now, right? So we'll take one more LED, we'll write the program. Okay, so I will repeat the same thing, and LED 1. So first time it has to be low. So when the green LED is low, the other LED sorry, when the green LED is high, the other LED will be low, and when the other green LED is low, the other LED has to be high. Okay, so this is your program. Okay, now come to your simulation. Okay, so you have to connect one more LED, right? So you take one more LED somewhere here. Okay, so let it be in yellow color. Okay, so 12th pin has to be connected. So we'll take the 12th pin. Here, and we'll take one resistor. We'll connect to ground. So as per this, we have written the program. Okay, so now let us see whether it is working or not. So first it has off. Okay, so since LED 12, okay, it's not configured, only LED 1 is working. Okay, now let us see what was the mistake we have done. We stop editing, pin mode out, LED 1, so 12 pin, so the pin is not connected properly, right? So okay, so I have reversed the connection, sorry, right? So positive has to be given, so I have given the negative. That was the reason why it has not worked. Now let us see. So now run the simulation. Yeah, so now see, yellow is also glowing. Okay, so since yellow we are unable to see, we'll take it for say blue. Okay, so now you can see here, right? So this is your code. Okay, so for suppose I don't want the program like this, right? So we have to change it. Okay, so here we can make it high. LED is low, then it has to become low, then it has to become high. Right, so now we'll simulate it. Okay, so let us say if you don't want this pattern, then we can select this and we can put somewhere here. Just run the simulation. Right, so you understand the sequence here, right? So this is your code. Now let us see the schematic. So this will be a schematic and this will be the components which we'll be using. So this is your in. Now okay, if you want to uh, do this, right? So I have used a small video so that you can see how the hardware is connected properly, right? So just give me some and stopping. I'll play that video so that you can understand how the uh, practically how your board will work. Yeah, so just confirm me whether the screen is visible or not. So which is a recorded one here. Is it visible now? The other screen. So I'm trying to play a video. Okay. So now see here. So whatever the code we have, so the same code we can just copy it. It may not be the same code. Okay. The code we are just copying it. Okay, and then we have to down for whenever we are working with an hardware. Okay, so this we have to take an app called as Arduino app. Okay, so this Arduino app is an flash tool which is used to dump your program into the Arduino. Okay, so I'll show you that also. Okay, so let us play this, then we see it. So this is your hardware setup. Okay, so Arduino setup. Okay, then we are taking one LED, then one resistor. Okay, so you can see the LED, how they identify the anode and cathode. Usually for the anode, there will be a larger pin. Okay, for cathode, it will be a smaller pin. So you are setting up in the breadboard. You are taking an resistor. So the cathode is connected to the ground. Then we can take a jumper. So using a jumper, you can connect that to a ground. So in this Arduino Uno board, so the ground is on the other part. Okay, in the simulation, the ground was just above the digital pins. Here we can take the just below the other part, right? Then we can take one more jumper and connect to the pin whichever you have been designated. Okay, so you have to ensure that the connections are well firmly fitted. Okay, so now we'll take the program and we'll copy it here. Okay, and we'll just run the program. So just save the program. Okay, then we have to run it. Okay, so just see. So once you save, okay, so the program, so you can see the LEDs keep on glowing, right? And then yeah, so you are changing the things. Okay, and you can change the delay also. Now you have to ensure how the Arduino is connected. Okay, so simple. First, copy the program. Okay, and paste it in the Arduino. Connect the Arduino board to the laptop. Okay, or your desktop. Then go to the tools. So you need to go to the tools. Okay, so this is for running. Okay, so go to the tools and select the COM port. Okay, first board, select the board. Okay, so you can select the board here. So whatever the board you are working, so the same board has to be selected, and then you have to go to the port which it is connected. Okay, so you can have many serial ports, but you need to identify to which port you are connecting. So usually the default COM port will be uh, 8, 9 and 10 only. Okay, so sometimes it will be COM3, COM2 also. So that you need to identify from your device drivers list, and then you need to go ahead. Right. So here COM4 is taken as a default. So once it is connected, then just run the program. That's all. Right. So this is of creating a simple project. So any doubts in this? Okay. So now let us do one simple task. Okay. So I'm going to share the task in the chat box. Okay. So control or develop a simple traffic control signals. Okay. So traffic control signals with a delay of say 5000 milliseconds. Okay, so the 5000 milliseconds in the sense 5 seconds. Okay, so will you do? So how to change the delay? So let us see how to change the delay before this. So here I have kept 1000, right? So now let us say after becoming low, I'll put only 100. I'll change the delay to 100, means 0.1 millisecond, and run it. So it is flashing, isn't it? So you can just change the things and you can do this. Okay, so now I'm just sharing the task. Okay, so any one student can do this and just display over here. So you need to develop a traffic control signals. Okay, so usually traffic control signals will be three colors, right? So you have red, okay, you have green and yellow. So these are the three LEDs you have to take. Okay, and for each and every for each and every signal there should be a delay of 5 seconds. So first red has to be there after 5 seconds, green, okay, for green should be for 5 seconds, and yellow you can keep it for mm, 2 seconds, right? So you need to just write the program properly. Okay, you need to connect the components and you need to write the program. So if you complete this simple task, then I will show you how to control with the help of input devices, input and output devices, how we can use a switch to control the LEDs. Sir, we can ask one student to do this and share the screen, sir. Sorry, yes, sir, your voice is not audible.
First of all, how many of you have joined using your laptop? Kindly raise your hand. Hello, am I audible to you?
Yes, sir, you are audible now.
Students, uh, please respond. Who have joined using your laptops? Okay, so now, Rusi, can you share your screen?
I'll stop the presentation.
Okay, sir.
Yeah, yeah, Rishi, you can just share your screen.
Uh, she may not be able to share. So, any other participant can share your screen.
ऋषि अगर आप लैपटॉप यूज कर रहे हो तो शेयर करो, क्या दिक्कत है? Are you trying to share your screen,
So if
Rishi?
you are, if any student is trying also, they can share your screen and do it, so that if anything goes wrong, you can just correct then and there itself.
Nikhil, Sakshi, Nisha, others.
Sir, may I share my screen?
Yes, sir. Yes, sir. Yes, sir. Please.
Yeah. Sir, is it visible?
Yes, sir.
Ah.
Yeah. So you are connected three LEDs now. So as per that, three LEDs has to be defined.
Yes, sir.
Yes. Uh, Students, you can just see how the program is being updated. So the basic program will be there once you take the components. Okay, so this basic program has to be changed. Yeah, so 5 seconds. Yeah, then green, then yellow. Yes. So yeah, so this is how. Right. So this is how we can use your LED. So there are n number of in there are many in output devices which you can control. LEDs are the most commonly used, so that one we have used for it, right, sir? So you can just change the LEDs properly, statuses, and then you can see. So we have used only 1 second, if I'm not wrong. So 1000 you have declared, so it will be for 1 second, the glowing. So anyhow, it is happening at any time. You can change the delay value and you can just improvise it. So I hope this is clear how to connect and how to uh, do the program. See,
So here I am getting one problem.
yes, sir.
Uh, so sometimes red and green, both the
Mm.
LEDs are turned on at the same time.
Okay, so for that you need can stop the simulation, sir. I'll just see what this. Yeah. So see here, first you made LED, which is the seventh red LED high, and it is turning for 1 second. Then you are making it as low. After 1 second, it will glow up. Then uh, you have taken your yellow, and for 0.1 second you have made it high, and after 0.1 second it low, and again this. So you can just run the program is fine only. You can just here, sir. So whenever you referred here, right, for LED2 first you made it as low.
Hmm.
It should be first high.
Okay, sir.
First it should be high, then it should be made low. So once your yellow is dropped off, then your green has to go. Now see, got it, sir?
Yes, sir. Yes, sir. Yes, I
Yeah,
got
fine.
it. Sir.
Yeah. So see, whatever the modification you are doing in this code, the same code you can just take it and dump in your Arduino app. Okay. So I'll share that Arduino app also for you right now. So sir, you can stop sharing it.
Yes, sir. Yes, sir. So I am just changing the delay and
Yeah,
see
yeah,
what is
sure,
happening.
sure, sure,
Sir.
sure.
Yes, sir. Just for a minute, sir.
So your screen is passive, I think. Oh yeah, fine. So you are increased for 10 seconds. Green
Yes,
light.
sir. Yes.
Yeah.
Yes, sir. Yes, sir. Yes, sir.
Red light for 10 seconds and yellow for 1 second light. Okay, fine.
Yes, sir. Yes, sir. Yes, sir. Hmm. But sir, whenever the red LED will become off, at the same time, I
Mm.
want to blow the green, yeah, sorry, yellow light, sir.
Okay,
Then,
so then you should not provide any delay here. After it is becoming low, okay,
hmm,
so the
hmm.
red light, so the delay function is there, right? That you can disable.
So, sir, may I make this
Yeah,
line as
below
null?
LED, before LED one delay function is there, right? In the fourth line, the loop function.
Yes, sir.
Yeah, that you can delete it and check it. Yes, you just start simulating. So the moment it goes low, immediately it will go to high. Yeah, got it, sir?
Yes, sir. Okay. Thank you, sir.
Yeah, fine. So I think one more student is sharing Nikhil. Yes, Nikhil, you can share.
Yes, sir.
Nikhil, are you sharing your screen? Yeah, fine. Oh, good. Okay, so you connected. Can you just illustrate that program what you had did?
Sir, I connected three LEDs at port
Okay,
number 7, 5, and 3.
okay, very good.
And for red LED, I do 5 millisecond delay.
Okay,
Then yellow 2 millisecond and green for 1 millisecond.
okay, right, good. So it's working, right?
Yes, sir.
Okay, okay, okay. So can you show your schematic? Yeah, so this is your schematic, right? Okay. So this you can download and you can just keep a copy also straight away. Okay,
Yes, sir.
fine. You can stop sharing that. Okay. So any other student who has completed
Yes,
this
sir.
task? Okay, okay, fine. So now, uh, okay. So now you can just see now for the hardware, what is the best app through which you can share the dump the program is Arduino app. Okay, so simply go to the Google. Okay, so just type Arduino app. So here you can see the software IDE. This is an open source Arduino software. So usually for all the projects with Arduino boards, this will be the best suit. Okay, so just uh, open that. Okay, you can directly download into the Windows, right? So Windows, if you have a MacBook, okay, so different changes you have, right? So you can just download it. Okay, so just click on Windows. You can have that. Okay, so it is freeware. Just download. If you want to contribute, you can contribute. So it will ask for an email. Give the email. Okay, so and download it. So now see here. See here. Arduino. So I think you are able to visualize this. Right. Okay, so I'll share. I'll stop sharing this. Okay, so this is the hardware. So this is about the output devices. Okay, so now let us work with some input devices. Now the same Arduino board itself will just control with a switch. Okay, so I'm going to remove the LED. Sorry.
Sir, your screen is not visible, sir.
Okay, okay, sorry. Yeah, so now I think it is visible. Okay, so now what I'm going to do is I'm going to control this LED, okay, with the help of a switch. Okay, so right. So now you require a switch, right? So for that, the available push button, whatever we have here, that we'll take it. Okay. So here, take them. Okay. So I'll connect over here. So how the push button is selected? So one terminal will be okay in, one terminal will be out. Okay. So the input terminal, this is an input terminal, and this will be your grounding terminal. So let us say this we are connecting directly to the ground. Okay, now input, for this input, okay, so they should we have to connect to 5 volts, or we have to connect to the uh, digital input pin. Okay, so let us say I'm connecting this pin to say 5th pin. Okay, so we are connected to the 5th pin. Now what we need to do, when we press the button, then only the LED should glow, otherwise it should not glow. So that is our setup. Okay, so now let us see the schematic whether it is cutting properly or not. So you have a switch, so once you close the switch, okay, the LED has to glow, right? So now for this, how to write the program? So you have set up the input, so you have set up the output, all this, right? Now you have to set up the 4th pin also, since it is connected to the 4th pin. Okay, so now here in the program, so we will just make it as int button equal to say some fourth pin. Okay, so this is what you have setting up. Then in the pin mode, your button is defined as an input port, right? So you understood what is the modifications we have done here. So first LED is an output port, and the input port is your button. Okay, so now here we are writing it. Okay, so whatever we have done, we have written for it. So let us delete pictures I don't want. Okay, so first you need to read the button. Okay, so for digital reading the button, right? So that's the input, so digital read. Okay, off, it is a function, so button is equal to low. Okay, so this is your function, right? So once you make this low, it has to off. Okay, so until, so low means pressing low. Okay, so digital button pressing low means we are giving the excitation. Okay, so if you are releasing, it is said to be high. So let us take this and put it here and make it high. So whenever it is released, your LED has to off. Off in the sense it should go low. Okay, so now delay function I'm not using here. So this program is until you press your so till you press your button, the LED will be glowing, and once you release the button, the LED will glow off. Okay, so you understood what we had done. So I'm removing the delay also. Okay, now let us see the simulation. So it has started. Now see here. So here we got an error stating that function void loop. Okay, so this button, there is some, sorry, I'm encountering some noise here. Can you mute yourself? Yogesh sir, I'm getting the disturbance from your end. Yeah, fine. So now we have initialized it. Okay, so let us see, we have corrected the errors also. Right. So we won't get any sort of blowing or anything because we have to make it low, right? So okay, so it is continuously on. So let us the programming was not done for this. So just add this also. So is there any impact of this push button here? No. Okay, why? Because serially we have seen. So it will check for whether it is pressed or not. Directly we are doing this, giving this digital read, digital write, everything. Okay. So what we can do is you can just make this as one function. First it has to return. So instead of that, we can put if condition, if your digital read is low, okay, then you can just disable this. Then your digital write should be high. Okay, and else, or again I'll put if your digital bit is high, you should make it as low. Right, so now let us simulate this code. Okay, so still it is low. So now what happened is, sorry, okay, so once we press it, not happen. Okay, so let me just correct this code where I went wrong. Just let me correct this. Yeah, instead of second, if we can write else, okay, let me just try that. Else will not be there, but still it will go with that. So no, I have declared it properly. See, so always it will be high only. It is continue. It has to delay. It has to stop it. Okay, so no problem. Uh, Somewhere I made a mistake. Let me see that. I'm just trying from my end. Just I'm stopping the sharing. Okay, 1 minute. Right. And still I'm getting some errors. So let me just yeah, still I'm getting some errors. Okay. Program is running, but actually when the button is pressed, then only it has to glow. So that is what I'm checking. So if the button is low, input pin mode, okay, fine. If digital read button is low, else right, 1000. Right, I'll just check this now. See, two things I have not done. First one was connecting your push button through 5 volts. Okay, so this one was missing in the earlier case. So have so these connections, two connections I have not used. Okay, so one directly we are connecting to the negative terminal. Okay, so now let us say, so this I'll connect to the ground. Then we'll take a resistor connected to 5 volts. Okay, so this is your 5 volts. Then can connect this to pin number, yeah, so pin number 4 we are connecting. So right, so now let me see the code. So code is, the button is 4. Okay, fine. LED is 7 connected. Now these are the two things modifications we are doing. Okay, so in the earlier case I forgot to give this positive to the switch. Okay, so that's the reason it has not worked. Now let us see. Okay, still it is not working. Okay, so now I'll just see this. I connect this, maybe because the previous of the because the previous status also it might be there. So I connect to this to 8. Right, so 8. Okay, now let us see. Take a new push button. Okay, so just give me some 5 minutes. So in that you can just take a break. I'll just close this. Yeah, go in. You can just share the thing, things.
Previous
Sorry,
lesson
you
and this one. we were only dealing with LEDs, but this time
Saurya, you are not audible.
Sir, now I am audible.
Hello.
Hello.
Yes, Saurya, tell me.
Sir, actually the LEDs would be connected through the switch here, sir.
No, that is what I'm just checking it. Okay, so I don't think so. This is not the thing. Let me see the schematic. Schematic is fine only. Okay. The LED cannot be, see, you're controlling LED, okay, with the help of a switch. And for this switch signal, we are giving the input through Arduino board. Okay. So just give me some 2 minutes. I'll just fixing it. In the meantime, you can just work on the other things. I'll give some other task. Okay. Develop an Arduino board for flashing 4 LEDs. Okay, 4 LEDs you can connect and you can just work on that. In the meantime, I'll just fix this issue and I'll come back.
the middle of the breadboard. Okay, we'll just leave it somewhere, and we will leave 2 more LEDs in different colors. One is yellow, one is red. And let's quickly make the connection. We will make one bridge using minus side of breadboard and Arduino. So the 5 volt has to go through the button. And quickly we will put the cathode sides to minus. We can do this by resistors, okay. It will be 220 ohm, and I can do copy paste, put another 2 here. And then next we will do one actually pin connection of the anode of every LEDs. You may change the colors if you like to. I may do this yellow actually, and this one is red. And let's go with the button. And the button, it will be different than others. So we will firstly make a resistor between 5 volts and the left side of the button. So there is a terminal 1A and terminal 2A. So we can call this left and right side. And the left side we will do one resistor connection, which is gonna do bridging between left side of the button and the 5 volt, okay. And plus we will do also one data cable, which will go to, let's say, number 4, okay. I will make this color blue. And another one gonna go to minus. I can make this brown. This is how the connection should be, okay. So now we will do like when these lights actually blink separately. Red gonna blink first and then blue, both blink in the and continue. Opa, let's make this okay, which is red. So first of all, opa, let's make this larger so you can see better. So first of all, we have to introduce the number. So I can go to write 4, and now the output we can write 2, but LED. So now it's time to give a command for those, and we will write commands. Now we can say if, okay, if devices, we like writing the desk. So you write from button. I will read the value from the button, and I will say if it's equal to high, which means if button is not pressed, okay, or let's say if button is low, okay, I mean, if button is pressed, this time it's gonna blink both LEDs in the same time, all right? So when I actually run this and I press the button, it will just blink it. But when I remove, actually when I don't press, it will stop it because there is no other action. All the actions are inside the if. In case you push the button, if the button status is low, actually when I don't press, I mean if button is pressed, this time it's gonna something on mouse, so you are giving the data, so you can only read this what's high at the same time. But when I remove, actually when I don't press, it will stop it because there is no other action. All the actions are inside the if. In case, we can also say else, the elements here, and then here in the middle, I mean in the bottom, we will write the commands. Now we can say if, okay, if. So this time, by the way, we were writing only digital write, right? This time we will do digital read. Sorry, I will write this inside. This time we're gonna read the value. So for input devices, we mostly read data, but for output devices, we write. It's just like, let's say, projector displays, like monitors, they show the data, right? So you write the data, you show the data there, like writing a desk. So you display the data. So they goes like for output devices. But for input devices, we say digital read. So you write something on keyboard, you write something on mouse, so you are giving the data. So you can only read this, what's written by them. Then we will say digital read of buttons, right? From button. I will read the value from the button, and I will say if it's equal to high, which means if button is not pressed, okay? Or let's say if button is low, okay? I mean if button is pressed, this time it's gonna blink both LEDs in the same time, all right? So when I actually run this and I press the button, it will just blink it. But when I remove, actually when I don't press, it will stop it because there is no other action. All the actions are inside the if. In case you push the button, if the button status is low, which means if anybody press the button, then it will run these codes, these selected codes. You can also say this else, but let's stop the simulation first. We can also say else. Else we will just make them blink, all right, separately. So I just write LED while LED 1 high, LED 2 gonna be low, okay? While LED 1 is high, another one gonna be low. No, I made it contrary. While LED 1 was high in the first, and the second it will be low, and the first LED 2 low, while in the second one it's high, right? Okay. So let's run it one more time. So we will observe that while we don't press the button, it will blink separately. But when I press the button, it will blink together. Actually, you don't understand the difference because there is really short interval between. So what if we make this 500? Maybe we can understand this time. So let me press the button now. Now it's more obvious. because I increased the delay time. So when I release the button, it blinks separately, but when I hold the button down, it blinks all together because of my codes. All right, so now we can quickly go on with the real.
Yes, Govind, whatever you have shared is fine, but if you can share the screen, that will be good. Right. So I'll come to the things where why my program was not executing. Okay. So the problem was I have overwritten the previous program. Okay. So which made the uh, Arduino board to work completely. Okay. So as per the previous things only. So let us see. I think my screen is visible now. Okay. So see, the program was one of the same. So what I did is I have changed certain pins. 11th pin and the 8th pin I have taken for coding. Okay. So then the same thing, pin mode LED output, pin mode BU, that is button. We have made it. I made it as input. Okay. Then if digital read, okay, is low. Okay. So low in the sense once you press, okay, that is known to be low. Okay. uh, so your LED is going to high and we are going to delay it for 1000 seconds, right? This is what we are writing. Right now let us start simulating. Okay, so now the button is high, so that's the reason it is not glow. So once you press the button, okay, so it will glow. See here. So once you just press the button, it will glow and it will be high or low. So if you comment this delay function, right? So now start simulating. So once you press, it will not glow. Okay, so until you are pressing, it will glow. Once you release, it will get off. So if you want this delay, right? So now you can just see here. So for 1 second it will glow and it will glow off. So if you want to glow for say some 10 seconds, you can just increase the delay and you can start simulating it. Now see. So for 10 seconds it will glow and it will off. Okay, so now this can be extended now for, let us say, let it be glow. Then we'll take one more LED. So once the button is released, the other LED has to glow. So we'll go to one more LED. So let us take one LED here. Take one resistor, and there was one connection which we have lost. Okay, so through the switch we are doing it. So we'll take this one resistor, connecting this to the thing, and one line we will connect, let us say, to the second pin. Okay, so now in the program, okay, so second pin is taken, so we'll make it int LED 2, and here also pin mode LED 2 equal to 2. So LED 1 equal to 2, comma output, right? So now here we are just giving some sort of thing. So when the button is low, okay, so this, let it be green has to be glow. Okay, when the button is not pressed, when the button is pressed, red has to glow. So okay, I'll write here else. Okay, can just take this. You can make LED 1. And 1. Okay, now let us see how it works. Okay, so first LED will be keep on going. Why? Because the LED this button is not pressed, so green LED will be keep on going. The moment we press, okay, so your LED is going to, red LED is going to glow. Okay, otherwise this will be there. So now see here, so red LED is glow once you press the push button, right? So like this we can create some scenario, right? So I'll give one more simple task so that you can just create it. So develop. Okay, so I'll give the logic. So first button is pressed. Okay, so once the button is pressed, two LEDs out of two LEDs. Okay, okay, that we have done, right? Two LEDs has to glow. Okay, second, when okay, so working also, right? The second is when button is released. Okay, so two LEDs has to off. That you can just try it, and anyone can share the uh, screen and show the code for you. Next we will see how to control the illumination of the LED. The students, you can just do it and share the screen. Anyone?